Hey everyone, welcome back to my workbench. This is my Paranoid edition here. I've got my static strap on. I've got the NES action replay here. First off, I've got this is the battery pack that's going to be the life support battery while I swap out 3.179. Check that one more time. 3.18 volts. Brand new batteries. Now, if we look on here, this here is the ground plane, and this is the positive for the battery. Still reading 3 volts solid. That's good. That means that battery is still in good shape. That's good. So what we're going to do is tack on a set of wires here, one for one to the ground, and then one to 5 volt power. I am trying to figure out here is the order of operations to put a battery on the battery holder in the back of this thing. Keeps getting stuck up in that corner. So the only issue I'm running into is, you see over here, this is the positive lead, which is this guy here. This one here, and this one here, and this one here are all positive lead. But this is the ground lead here. And unfortunately, this ground lead is buried underneath this battery. So I need to figure out how to what order I need to go in. So I'll probably I'll tack on the life support battery, pull off this one, and then put the other battery in place. And I should have just enough room. Yes, I will. I'll have just enough room on the side. Which way does it go? The positive lead is this one. The positive lead, I'll probably end up, I'll solder it in place a little twisted, and then turn it over to snap it in the right spot. Or do I go to that one? Either way, I'm covering it. So I think it's going to go right like this. I'm not touching anything yet. So this will go here and here. Double check, make sure. Looks like the design is there's no continuity, but I am paranoid. Between the negative lead and the positive lead, nothing. Negative lead, positive lead, nothing. I can see they actually cut an area out in the stamp, so you can't accidentally short those together. Alright, so let's figure out a ground place that won't interfere. Because if I go to this pad here, when I go to solder and desolder, there's a chance I can knock it off. And I don't want to do that. So I see this pin way over here, or this pin here. Electrically is all the same point. So that is definitely the ground pin. You can see they actually ran a trace all the way around the board, one side to the other, which is good engineering actually to do that. So we're going to install the life support battery here. Took all my rings and jewelry off and watch off, so there's no chance of anything shorting out. That's the last thing I want. So tin this up real quick. Let's go over here. Maybe up in the corner. We're going out in the corner up here. Yeah, a little more solder. turn my iron up very slightly, temperature wise. Good solid connection there. Let's go up to 650. Okay. And then the positive lead, we'll double check that a third time because I'm really paranoid. Volts. Here's your 3 volts there. You got your 3 volts there. You got your 3 volts there. This is a reference. This will be about 3.1 volts here. 3.1. Okay. So I will tack on to this little point right here. That way it'll be a way. I'm not going to unsolder that connection until I have a battery in. It goes there, there, and there, and I don't think it goes anywhere else I can tack on to. Nope, it goes through a diode after that. Yeah, so I'm wearing my static strap too, just to be sure. This is going to add this in parallel. So I'm doing it with the batteries in place, so if there's a problem, it'll drain this battery instead of the button cell that's on the board. And once I do this, we should see a little higher voltage just because these AA's they're really fresh, so they're running a little higher than 1.5 each. Double check. .14, so yep, that's good. That means this guy is reading correctly. Yep, it's just a little higher than the 3 that was there. Now, I'm going to tape this down temporarily. Just to make sure. I don't want to rely entirely on the solder connections. Conceivably, you can leave it like this forever, because, well, until those AA's run out. But those AA's will power this circuit up a couple years. So I'm going to cover those up. Just taping that down just to give a little extra mechanical advantage. Yep, good. Still got 3 volts there. Alright, so now we need to unsolder the existing button cell. Let me think here a minute. Alright, so that's your negative lead. Your negative lead is this post here. So a negative lead is going to sit just like that. Where's that battery sit? If it sits like this, or it sits like that. I think it sits like this. So if we take that battery off, solder this one in place, but I may be able to solder, yeah, I'll have it soldered up like this. No, I'll have it soldered the other way. I'll have it soldered up like this. So I can solder this one in place and then pop that down and solder from the back side. Okay. First comes first is the desoldering. So in the future, what this will allow is, if you want to swap the battery, it won't matter because it'll just be as simple as pop one on the back, pop a new one on the front, and then take the one in the back out. Man, that's a lot of solder in there. Glad I stuck the bigger tip on this iron today. Luckily, this life support arrangement here allows you to really give you plenty of working time, since double A's last a long time. Just trying to see how to finish getting the solder out of here. I don't like how they did some of these old boards where they permanently soldered the stuff in place. Just, it's like, why? Why would you permanently solder a battery? It makes no sense. Yeah, if it was me, I'd do like what they did on those old Palm Pilots. They had, you had to swap the batteries out every now and then too. So what they did is they put a a large capacitor on there. So while you're swapping the battery out, it would hold. Let me check the patience here. Alright, so still fighting. Okay, I see some daylight through that one. This one on this side is not going to move much. Get a plastic spud here. Hold on. Here's a plastic tool. Okay. Not conductive. Just want to get a little bit of leverage. See if I can pull this out at all. Come on. And I don't know why they wanted this design. It's moving somewhat. Hold on. The other side's the problem. I thought this side was the problem. So before I do the final yank out, I'll check the voltage one more time and confirm that it's the life support battery. There we go. Still life support battery. Good. Okay, she's rocking and rolling. Come on, you can come out now. I'll just cut it close. Oh, where's my good clippers? There. That one's loose. One side's free. Come on. Side doesn't want to come out. Why? move. Get her to move out. Come on. There she is. Oh, that's the replacement battery. Yay. Okay, still got 3 volts there. So, still got plenty of juice. Only have about 5 or 6 years to work on this now. I'm actually quite impressed with that button cell still showing 3 volts. After, I mean, who knows how old this was? Let's see a date code on it. Yeah, it doesn't say, it doesn't have a date code on it, but that's still kicking out a nice solid 3 volts after all these years. That's actually kind of impressive. A few months back I was working on an IBM. They did the same thing. They had a soldered in motherboard battery. I think it was even bigger cell than this. That one I think was the same exact battery they use for tire pressure sensors on your car. Alright, so life support battery is still in place. Battery is still showing 3 volts. Alright, so now how do I go in this order of operations? So, negative is this post here. That post to that post. How does I block more or less both of those as I'm going down? How did they intend this to work is the question. So, negative is this post. Negative goes there, positive goes there. I can only access the other one from the other side though. How do they intend this to work is the question. Dear engineers from long, long ago, help me out here. I'm going to do that and then I'm not going to be able to access it. Maybe if I do this one, I kind of pop it up in the air. And maybe that's what they need to do. I need to make a little bit hoopty. Keep that straight. Yeah, that's the negative lead. That's the positive lead. How do I fit this in is the question. And what's the order of operations? Because I need to be able to access that. Let's call you the top one. Negative lead goes over here. Positive lead goes over here. So I need to be able to access. Let's see. Negative lead goes there. Positive lead goes here. Oh, see. I can go in here. Oh, wait a minute. Maybe I'm overthinking this. Okay, that. is negative lead, positive lead. So I can still access that post. This is turning into quite the puzzle. Negative lead, positive lead, positive is there. Negative lead, positive lead. Might have to trim these down a little bit. They were intended for really thin holes. Still good? Everything's still good. Okay. The problem is the posts they use on these batteries are a bit thicker than the batteries than they have here. Let's see. I had to do this before too. I actually had to thin out the lead a little bit, or it just wouldn't fit. Negative lead is my thumb side. Negative lead, positive lead. Oh, wow. That does not want to go. Gotta trim it down a little more. Those holes are completely cleaned out too, so I can see here. Yeah, those don't go through. Let me see. Do I squish them up or do I trim them more? It's the problem I've run into before, actually, is the leads are too thick. Still too thick. Oh. And they need to be really flush too, or you're not going to get it. Life support is holding. Should I grind it? Yeah, probably should grind it. I need to get both of these ground down so they're small enough to go through these holes. This is actually the safest position like this because there's no conductive components hitting the table. Okay, I'm going to grind these down a minute. I'm not going to make everyone watch me use my Dremel tool. I'm just going to grind these so they're a little bit narrower so they'll actually fit in the hole. So let me pause a minute and then try that. Oh, okay, sorry, I kind of skipped ahead here a bit. I forgot I wasn't recording. I had to do a couple things. I had to figure out the order of installing the second battery. So I've got the new battery installed on top here, and it's actually reading, and I have the new battery holder installed on the bottom as well. And you can see if you hook into the ground, oops, wrong way, Dave. You're going to hook into the ground, jeez, ground here, and you can actually see there's about 3.2 volts. The new battery actually has higher voltage than this guy here. So now all that remains is to pop off the the life support battery, and as far as I can tell, see, that is the positive on top, and on the bottom, and it's reading higher than it was. So, moment of truth here. So when I pop this off, you should still see power. This is the only part that scares me, but it shouldn't. I don't know why it is. It's on there. Let's hope the lid closes when this is all done. Okay, double check the voltage one last time. We got good continuity here. Yeah, I got 3.2, which is higher than it was before, so the other battery is on there. So let's carefully pull off the life support battery. Let's see what we get in here. Yep, 3.2 volts. So the new battery is in place. So I am going to leave this little bit of Kapton tape on here because I'm a little worried about this guy moving around and causing damage. Causing a short. It's the last thing I want. I hope this thing seals back up. The height is a little bit questionable, but I have it down as low as she'll go. I have a little bit of interference with this capacitor here, but width-wise, I think we'll be alright. Let's take a look here. Where's the other half? Yeah, that's my biggest worry is, will it fit back into the housing? It's still a little bit thicker than it was. Oops. What the heck are you doing there? Silly tape. I discovered the plastic for these battery housings is a really high temperature. See, this is my worry about this battery holder, is you could see how the height, the problem is I really can't go any shorter because I cut all the way down to the shoulders on these pins here. That's my worry. It's just not quite sure where to go with this because the height is just way too high. Well, I'm sure Clint will see this video, and I'm not sure quite what to do here because I mean I don't know how much more. I can't really do much more trimming. I mean, it's not even like close right now. It's a good. I would say a good 1/8 of an inch high. Because the problem was they designed it originally is this original battery height. I mean, you can see how much lower. I mean, it was like that on the board. You can see how much more height it takes up there. So, oh, Clint, let me know what you want me to do. I still have the original battery. But I don't know if that's a very good option there. And yeah, is regardless of where I put on the board, the height of this battery holder is just, it's frustratingly high. So well, I'm gonna lay it back in its housing either way for now. A neat piece of hardware, but it wasn't really designed for these battery holders. I was worried about that when I started this, and I'm a little bit even more worried now. It's like, okay, where do I go from here? As you can see, the housing is kind of good. Oof. Housing back at this end, I mean, it's like, you know, 1/4 of an inch maybe, height-wise. Even if I relocate this somewhere else, I don't know if it's going to help much. Shoot. Alright, I'm going to leave this as is. I'm not going to mess with it anymore. The new battery's in there for now. I still have the old battery, and we're going to figure out what the heck to go from here. So that's it for tonight.